guys, welcome back to round 2. Okay, so in round 1 we were working with complex numbers. What did we do with them? Well, first of all, we simplified square roots of negative numbers. We took their product and quotient, and then we took complex numbers and then we added them, subtracting them, and multiplied them. Okay, so that was round 1. Okay, and then round 2, we're gonna go ahead and divide them. Okay, but before we do, let's go ahead and talk about complex conjugates. Complex conjugates just kind of reminds me of regular binomial conjugates. Okay, so we had talked about, conjugates. What's the conjugate of a binomial of the form a plus b? So we had said to find the conjugate of a binomial, we're going to take the first term and then switch out the sign on the second term. So copy opposite. Now, complex conjugates, what are complex conjugates? Well, coming back to conjugates are binomial expressions that differ in a sign. So complex conjugates, what are those? They are complex conjugates are complex numbers that, you guessed it, differ in a sign. So if I have a complex number of the form a plus bi, then what would be the complex conjugate? The complex numbers, I have to see how I phrase this. The complex numbers a plus bi and, okay, I thought I had phrased it like the complex conjugate of a plus bi is, but I didn't. Okay, so I'm like, okay, what's the complex conjugate of a plus bi? I'm like, conjugate, copy opposite. Conjugate, copy opposite. Okay, so conjugate of a plus bi is a minus bi and vice versa. Okay, now why is this important? Now the reason why it's important is because when we take a complex number and multiply it by its conjugate, we're gonna end up with a real number. So let's do this. So now for the nitty gritty, or the meat of this section, okay, the division. Okay, how do we divide complex numbers? Let me go ahead and write down our first problem. How many are we doing? Just 2. I know, I can't believe it myself either. So we have 5 plus I over 3 minus I. Okay, the directions, just read simplify the quotient, okay, and write your answer in standard form, a plus bi. So in this case, we don't have the traditional division sign, but remember the fraction bar is also used as a division symbol. So this is our division unit. The question is, how do we divide complex numbers? To divide complex numbers, you're just going to pretty much multiply the top and bottom by the conjugate of the denominator. It's kind of like when we were rationalizing the denominator, it's similar to that. We want to make the denominator a real number. Okay, so to divide complex numbers, you're going to multiply the top and bottom by the conjugate of the denominator. So I'm like, okay, how do I divide complex numbers? I gotta multiply by the conjugate of the bottom. So conjugate, copy opposite. Conjugate, copy opposite. We want to have good notation, so let's make sure that we wrap up our complex number or a two-term expression, including the originals, numerators, and denominators. Now we gotta simplify the top, simplify the product. So take the products. It doesn't really matter which one you do first, but for me, I just want to make sure that we have a real number in the bottom, or in English, I want to make sure that the I is gone. So this is why I will always attack the denominator first. Okay, now depending on how comfortable you are, you can take the multiplication shortcut. Product of conjugates gives us a difference of squares, but when you're a little bit nervous, you forget your name, so I'm just gonna FOIL it out. Okay, product of the first terms, namely 3 in itself, will give us 9. Product of the outer terms, 3 times I is just 3 times I. Product of the inner terms, negative I times 3 is just negative I times 3, or 3I. Product of the last terms will give us negative I squared. Okay, so if we did this right, when we multiply the top and bottom by the conjugate of the denominator, we should get rid of the I in the bottom. So let's do this. So when we continue to simplify, that will leave us with 9. Sum of 3i and negative 3i will leave us with 0, because they cancel out. And again, if you have an I left, it needs to be I itself, not I squared, not I cubed, not I to the 4th. I'm not in the habit of memorizing things, so I'm just going to build it up. What I do remember is that I equals square root of negative 1, and I want to build it up to I squared. So we're going to go ahead, square both sides, And when we do, the square of I is just the square of I, or I squared. On the right side, the square and the square root undo each other, and that will leave us with -1. Okay, so again, it's faster or easier for me to build it than it is to remember what I squared simplifies to. So we have a negative sign, and then I squared, which simplifies to -1. This is like too much space for me, so let me go ahead fix it so it's closer to each other. So that will leave us with 9 minus -1, and the difference of 9 and -1 gives us 10. Okay, if you want to write the subtraction problem as a related addition problem, go for it. Okay, so the question, or the $1,000,000 question that I'm going to ask myself is this: did I get rid of the I in the bottom? We sure did. So let's go ahead, bring down our problem. In the numerator, we have product of 5 plus I. I was going to say 5I. We have product of 5 plus I and 3 plus I, and that's all over 10. Okay, so what are we going to do? We're going to go ahead simplify the numerator. And if it turns out that we have the real part and a pure imaginary part, then we're going to have to split it so we can highlight what the real part and the pure imaginary part is. So let's do this. Product of the first terms, namely 5 and 3, will give us 15. Product of the outer terms, 5 times I is just 5 times I. Product of the inner terms, I times 3 is just I times 3, or 3I. And the product of the last terms, product of I in itself, is of I squared. And that's all over 10. Okay, let's take our time, earn our full credit, and then we'll be almost out. When we combine like terms, the sum of 5I and 3I will give us 8I. And then we're going to add to it whatever I squared simplifies to. We're not going to build this again. We're just going to build it once per problem. And thanks to our hard work, I squared simplified to -1. Okay, we got this. Okay, let's not rush ourselves. Let's take our time and continue to simplify the numerator. In the numerator, we have 5I plus -1, and that sum will give us 14. Let's bring down the rest of the problem. Okay, so now, normally I would ask myself, I got a fraction, is it reduced? But in this case, right now, I'm not too concerned with is a fraction reduced. What I'm concerned with is this in standard form. So I'm like, is this in standard form A plus BI? Give me a moment. Sorry about that. We had some technical difficulties, but we're good. Okay. So again, we have a fraction. Under normal circumstances, I would ask myself, okay, is this fraction reduced? But in this case, because we have an I tossed in there, what I want to ask myself is this bad boy in standard form? Do I have the real part separated from the pure imaginary part? And we don't. So let's go ahead, split the numerator. Okay, so we're going to take the first term, namely 14, fraction bar, divided by the denominator 10. What is the operation? It's addition. So we're going to add to it the second term, which is 8I, and then divided by the denominator 10. Now that we have split it, now that we split the real part from the pure imaginary part, now I have the green light to ask myself, are both parts reduced? And in this case, they're not. For the first part, 14 and 10 have a common factor of 2, so let's do this. 2 goes into 10 5 times, and into 14 7 times. So that will leave us with 7/5. Okay, so that will leave us with 7/5 plus 8 and 10 have a common factor of 2, so let's go ahead and reduce it. 2 goes into 8 4 times, and into 10 5 times. So that will leave us with 4/5. And for aesthetic reasons, I'm going to put the I in the middle. But if you want to put it with the numerator, that's fine. Okay, the most important thing is, did we separate the real part from the pure imaginary part? And we sure did. Okay, so for this problem, we were going to do 2 problems. So this is our first problem. Let's go ahead and knock out our second problem. Okay, so second problem has been identified. Let's go ahead and do this. And remember, pause and rewind as many times as need be. Okay, so we have a complex number in the top, complex number in the bottom, and they're separated by a fraction bar. So in this case, I'm going to ask myself, how do we divide 2 complex numbers? It's like, oh, to divide 2 complex numbers, we're going to multiply the top and the bottom by the conjugate of the denominator. So I'm like, what's the conjugate of -I? I have no idea. I want to write this in standard form, A plus BI. Okay, If we don't have two terms, then we're just going to fidget. Okay, we're going to write it as a two-term expression. We're going to write it as 0 minus I. 0 minus I is still negative I. I need this. If you don't need this, I don't need it. Okay, but you don't take the test for me, so I got to do what I got to do. So let's go ahead and rewrite our fraction. Okay, so we have 5 minus I over 0 minus I, which is just undercover negative I. So I'm like, okay, well, how do we divide complex numbers again? Again, to divide by complex numbers, you're just going to multiply top and bottom by the conjugate of that denominator. Conjugate of 0 minus I, let's do this. Conjugate, copy, opposite. Conjugate of 0 minus I, copy, opposite. We want to have good notation, so let's go ahead and wrap up our two-term expressions. Okay, the 0 has served this purpose. Let's go ahead clean this up without the zeros. Okay, so our numerator, we have 5 minus I over the denominator is just negative I, and the moral of this story is that the conjugate of negative I is, you guessed it, just I. So essentially we're just multiplying top and bottom by I, but let's have good notation. In the numerator we have two terms, so it's vital that we wrap it up. If not, the reader will think we're just multiplying the I by this I. Okay, let's clean up the bottom. Product of negative I and I will give us negative I squared. Okay, remember, if we're gonna have a reference to I, it's just gonna be I itself, not I squared, not I cubed, not I to the millionth power. Again, I'm not in the habit of memorizing things, so I'm gonna build it up. Oh, but why if we already did it? Yeah, but I'm gonna build it once for every problem that we knock out. So let me do a thinking area. The definition of the imaginary unit I represents square root of negative 1. I'm going to square both sides so that way we know what I squared simplifies to. When we square both sides, the left side will leave us with I squared, and the right side will leave us with negative 1. And in less than 10 seconds, maybe longer because that's how I speak, and in less than 10 seconds we have that I squared simplifies to negative 1. So we have I squared simplifies to negative 1, but what do we have right before it? We have a negative sign. So pretty much I want to know what's the opposite of negative 1. Opposite of negative 1 is positive 1. Or we can just say, like, two negatives make a positive. No one will ever know. Okay, so after all that hard work, in the numerator we have 5 minus I. We got to multiply it by I, and that's all over our simplified denominator. Sorry about that. That's all over our simplified denominator of 1. But when the denominator is 1, we really don't need it. Okay, so let's go ahead, omit it. 5 minus I times I. Okay, no more denominator. Oh, okay, that was a nice surprise. Let's go ahead, take our time, take this product, and then make sure that our answer is in standard form for a non-real complex number, a plus bi. We're going to go ahead, distribute from the right side. So product of I and 5 is 5i. Product of I and negative I is negative I squared. And you know the speech. If we have a reference to I, it needs to be I, not I squared, and etc., etc. Okay, so we have 5i minus whatever I squared simplifies to. And from a few moments ago, we had said that I squared simplifies to negative 1. Let's clean up our expression. Okay, subtracting negative 1 is the same as adding 1. And this is our answer. It is correct. Okay, we cannot simplify further. Although this is correct, it's not accepted for full credit because it's not written in standard form. Okay, standard form for a non-real complex number is a plus bi. So we need to see the real part first, followed by the pure imaginary part thereafter. Okay guys, so I said we were just gonna do 2 problems. This was the second problem, so we're out. Thanks.